Alright guys, Bismillahirrahmanirrahim. This is Math and Aber Ma. Welcome to Ma. This is vectors question number 10 from paper of 2018 summers. Okay, the question is has given provided you two of the coordinates A and B and asked you to find midpoint. In order to find midpoint, we add the two x coordinates and take their mean, and we do the same for the y coordinates, and the result here would be -1, and that would be half. The gradient is denoted by the change in y over change in x, or you guys call it rise over run. So basically, the rise over run for AB would be 2 less -1, then 2 less -4. You get 3 by 6, and that would come to half. Okay, now you have this show that BC is perpendicular to AB. Okay, so I denote the gradient of BC by this, and that can easily be find out. Okay, some of you might be thinking how to find the coordinate gradient of BC since the coordinates of C are not even provided in the question. No problem. We have been provided the vector BC, and how do we know it's a vector? Because of this particular arrow over its on top of it. When you have a vector, so basically what you have is you have the root from B to C. So that is what we need. That is essentially what we need for a gradient. So we know in order to move from B to C, we need to move 4 places. So x2 minus x1 is 4. And in order to move from B to C, we need -8 down. So that is y2 minus y1. So x2 minus x1 is right, and y2 minus y1 is down in this case, and that is actually the gradient. In order to find the gradient, I would plug in here y2 minus y1, that would be -8, and x2 minus x1, that would be 4. So I get -half as the gradient of BC. Since you can see the gradient of AB in part B over here was half, so multiplied by the gradient of BC that we just got -half, if you multiply these two, um, so you should get 1. Okay, my bad. This is not -half. This is -2 over here. So -2 times, or you can say half times -2 should gives you what? It gives you basically -1. So that is actually what we know as a matter of fact, that should be the product of two lines gradients if they are perpendicular. So their m1 times m2 should be -1, and that's we have got, and that is sufficient for gaining 2 marks for this part. The last part of the question asks you to find the coordinates of D given that A, B, C, D is a rectangle. So by now, let's list down the coordinates that we have. For A, in the question it was -4 and +1. For B, it was 2 comma 2. Okay, it was -1, sorry. And then for C, it was we haven't found out yet for C. Okay, so let's find out. Since we know BC is for the position vector for BC, column vector for BC is 4 -8, and we know that B is 2 comma 2. So in order to move from B to C, what the question is telling you, you can simply move, like if you have 2 comma 2 for B and you want to go to C, what are you going to do? You are simply going to add 4 to 2, and then for C, this is for C, and you are simply going to add -8 to 2 because you are currently at the line B. So let's think of it like this, and you have this particular line and you are at B and you want to move to C. So you know the coordinates of B, but you do not know the coordinates of C. But you do know that in order to move to C, what you need basically this distance, horizontal distance, which should be 4, and then this okay, this is not positive, this is actually negative. You need to move down like this over here, and that should be -8. So C is not on the top of B. Okay, C should be here. C should be here. Okay, so yes, now we have 4 and then -8. So you can easily figure out what the coordinates of C should be. So C should be 6, comma, -6. Now we don't know for D. Okay, in order to find the coordinates for D, what you can do is make a rectangle here for better visualization. And if you have a rectangle A, B, C, D, so you want the coordinates of D. That's all you need. Okay, so by using the triangle law of vectors, if I make a triangle over here, so my D comes out to be, okay, even I can go for this method like this, but even easier in this case, even easier, and I would prefer that, would be that definitely you are going to have somewhere your um, x-axis and your y-axis, right? So this particular point is A, and you have origin right here. So if you want to find the coordinates of D, you can simply go to OA and then you can go to AD. That's it. So that is going to give you the coordinates for D, because if you know the coordinates of A, and that you already know, that is -4, -1, because any point on the Cartesian plane is actually the distance or the vector from the origin to A by default. So A can be said to be OA, right? So this I took from here, -4 and -1. Then AD I don't know, but I do know, what I do know is BC. Right here I have been provided in the question with BC. See here, this is BC, right? So if the BC is provided to me, the same would be for AD as per the properties of a rectangle, right? So rectangle tells us that whatever the BC is, it's going to be, AD is going to be the same. So I substitute the BC's column vector in place of AD, and I finally get my answer 0 and -9. So that should be D, because you know, or you can also call it OD. So OD or D simply is going to be this, and in the form of coordinates, as the question asked you for answer in form of coordinates, so you should always give in the form of coordinates, and that should be 0 comma -9. That was it for this particular part. Okay, and for the next question, you can go to this. Okay, so this is another question for vectors, and over here you have been asked to find the position vector OB of point B. Okay, so since you have the position vector for A, and as I said in the previous question, you can best imagine using Cartesian plane that your origin is always here.